Let's have a look at another question that involves rationalizing the denominator of a fraction. This one involves 3 surds in the denominator instead of 2. So immediately looking at it, do I use the difference of 2 squares method here? What do I multiply the denominator by immediately to rationalize all 3 terms? And the answer is that we've got to sort of do this over 2 steps because of the 3 terms. So the way we've got to look at it is if we can eliminate one of the surds first, then we can focus on the 2 that are remaining. So let's start off by defining let u equal, might just put here, let u equal root 5 plus root 7. You'll see where this is going shortly. What I'm going to do is I'm going to treat these 2 terms really as a single term. Okay. Then we can apply sort of difference of 2 squares method here to at least rationalize out the root 3. Okay. So what we have then is if we then write the fraction, we can write it now in terms of u. So 1 on root 3 plus u, since u is root 5 plus root 7, we can just write it this way. Okay. Now what we're going to do is sort of apply the multiplying sort of the numerator and denominator by the conjugate of the denominator. So that's going to be root 3 minus u over root 3 minus u. So that's all well and good. That we've seen before, hopefully. But we're working in terms of u, so let's see what happens. Okay. So multiplying out the numerator, we go root 3 minus u over. Now we're going to have 3 minus u squared. But what's u squared? All right, so if u is root 5 plus root 7, okay, that's going to be root 3 minus root 5 plus root 7. Okay, so that's in the numerator. And what we have now in the denominator is 3 minus u squared. So that's going to be root 5 plus root 7 all squared. Okay, so let's keep going. Let's expand out the brackets. So we have root 3 minus root 5 minus root 7 over 3 minus, and that's expands sort of what's inside the brackets there. That's a perfect square, of course. So we're going to have 5, okay, plus 2 root 35. Okay, so root 5 times root 7, we're going to double that, of course, and it's a perfect square expansion. So that's going to be 2 root 35, great, plus 7. So I'm just going to draw a vertical dividing line there. Okay, so let's keep going. So that's going to be equal to root 3 minus root 5 minus root 7 all over. Now we've got 3, sort of 3 minus 5 minus 7. So if you sort of expand the bracket here, the negative gets sort of weaved into all these terms then. Okay, so 3 minus 5 minus 7 is negative 9. Okay, and minus 2 root 35. Okay, I guess just what we'll do is that we'll multiply top and bottom by negative 1. Again, I like to just keep things clean, as we sort of move along. And in doing that, that's going to make the root 3 negative and the root 5 and root 7, it's going to make that positive. So, alright, so we'll end up with root 5 plus root 7 minus root 3 this time, because when you multiply by negative 1, you're reversing the signs, aren't you? And the denominator, the negative 9 and the negative 2 root 35 become positive. So it's kind of nice. Plus 2 root 35. Okay, so far so good. And what you notice now is that we've converted, I guess, the original fraction. So I'll go back there. Sorry, the original fraction, which has 3 surds in the denominator, now into a fraction that has actually 1 surd, which is very nice. I didn't think we were going to be that successful. That's even better than we expected. Fantastic. Let's now apply the difference of two squares method yet again, multiplied by the conjugate, in other words, of the denominator, to rationalise out the root 35. So this one, hopefully you may have seen before, of course, we just have two terms multiplied by the conjugate, so it's going to be 9 minus 2 root 35. Okay, probably at this point we've now got to we've got to start to be careful now because it might get a little bit messy. So 9 minus 2 root 35. Okay, I think we're happy with that. Yep. Okay, so let's multiply the numerator through. Okay. I'm going to write that a little bit smaller just so it all fits. Right, so 9 multiplied by all of that, and then hopefully we'll collect some like terms and simplify surds where necessary. So we've got 9 root 5, okay, so hopefully you can read that, plus 9 root 7 minus 9 root 3. Okay, so no surprises there. And then we're going to minus 2, okay, and 35 times 5 is 175, of course, so minus 2 root 175. Then we're going to have minus 2 root, I think it's 245 from memory, so 35 times 7 is 245, of course. Good. And now we're going to add something here. So we've got a negative root 3 times negative 2 root 35. So that's going to be plus 2 root 105, actually. So 35 times 3, 105. Yeah, and we just managed to squeeze that one in. All over. Okay, 9 squared minus 2 root 35, all squared in fact. So that's going to be, in fact, just all at once on the calculator. That's 81 minus 4 times 35, so 4 times 35, and we get negative 59. Okay. Of course, in an exam situation, you probably think I'm panicking here. What do I do? You can just type it in. Right? If you ever get stuck, and just make sure you type it in neatly. Or carefully, should I say? To write it from write neatly, but type it in carefully. You get negative 59, so that's great. And let's see now if we can maybe tidy up the numerator a little bit, and then we'll compare the value of this to the original fraction, the evaluated versions. We'll see if they're the same. So that's going to be 9 root 5 plus 9 root 7 minus 9 root 3. Now, root 175, we've got a 25 in that, so it sort of seems fairly obvious there. 25, that's 175 is 25 times 7. That's 5 root 7, isn't it? Yep. So 175 is 5 root 7, so the 5 can come out, it becomes 10, isn't it? So it's going to be minus 10 root 7. Okay. 245, 245, maybe divide by 49. So yeah, that's that's 7 root 5, isn't it? 7 root 5. So take the 7 out. It's going to be minus 14 root 5, and 105 can't do much with. All over negative 59. Okay, now let's see if we can combine some like terms, and probably we'll just end it at this point. And we can keep simplifying, over and over and over, but, it's, let's see, 9 minus 14, negative 5, isn't it? So, negative 5 root 5. So, just to make it easier, I'm just going to put a little dot over the ones that I've sort of used up. Okay, we got some root 7s there, so 9 root 7 minus 10 root 7, that's minus root 7. Yeah, so that's great. Put a dot on that and a dot on that, just so I've used it up. Minus 9 root 3. Yep, gone. And plus 2 root 105. All over negative 59. Okay, now let's see if we got this correct. or at least close enough. Because remember that calculator can never express a surd exactly unless it writes the or unless it expresses the answer in surd form, which at least currently in NESA rules you can't use a calculator that does that. The answer's got to be decimal form. Let's start off with the original fraction. So this one here. Okay, so you've got 1 over root 3. Okay, plus root 5 plus root 7, and we get this decimal there. What I might do is I'll just type in our. I might just move that over a little bit. Yep, that's great. You can see that hopefully. Let's type what we just came up with there and see if that works. So negative 5 root 5 minus root 7. Hopefully it works. 9 root 3. Okay, should put a drum roll in the background. All right. Oh, sort of all waiting in suspense. Aha. There you go. I think we're reasonably confident that what we just came up with there is the rationalized version of this. All right. Hope you enjoyed this video. Thank you very much for watching.